When we think about space travel, we often picture fast rockets and quick trips. We imagine zipping between planets in months or years. But the true scale of our cosmic neighborhood is something else entirely. Consider the Voyager 1 spacecraft. It's the fastest object humans have ever sent into the void. Yet, its journey to truly leave our solar system isn't a short sprint. It's an epic marathon that could take anywhere from 300 to 30,000 years. This vast range in time tells us a profound story about the immense, almost unimaginable emptiness that separates the stars. It forces us to think not in human lifetimes, but in the lifetimes of civilizations. Voyager 1's mission began in 1977. It was a time of great curiosity and ambition. We wanted to see the giant planets of our outer solar system up close. Jupiter with its raging great red spot, Saturn with its magnificent shimmering rings. Voyager gave us our first detailed family portraits of these distant worlds. Its cameras revealed volcanic moons, hidden rings, and atmospheres churning with storms larger than our entire planet. After completing its planetary tour, its mission was extended. We aimed it toward the stars, sending it on a one-way trip into the great unknown, a journey with no final destination in sight. The question of when Voyager 1 leaves the solar system depends on how you define the border. If you think of the solar system as the area filled with the sun's wind, the heliosphere, then Voyager 1 has already crossed that frontier. In 2012, it passed through the heliopause, the turbulent boundary where the solar wind collides with the interstellar medium. It entered a new realm, a place where the particles and magnetic fields come not from our star, but from the vast expanse of the Milky Way galaxy. It is now, and forever will be, an interstellar traveler. It's the first human-made object to breathe the air, so to speak, of the space between stars. But the sun's influence extends far beyond its wind. Its gravity, the gentle but persistent force that holds our solar system together, reaches out for light years. While Voyager 1 has escaped the sun's plasma bubble, it is still very much a captive of the sun's gravitational pull. It's like leaving your house and walking down the street, but you are still in your hometown. To truly leave the solar system means to escape the sun's gravitational grip entirely, and that is a journey of an entirely different magnitude, one that requires us to stretch our imagination across immense spans of time and distance, far beyond anything humanity has ever experienced directly. Let's trace Voyager 1's path on the cosmic map. Launched over 4 decades ago, it used a clever gravity assist maneuver, like a cosmic slingshot, to catapult itself from one giant planet to the next. This gravitational dance gave it the speed it needed to eventually escape the sun's immediate pull. Today, it is more than 160 times farther from the sun than the Earth is. Light, the fastest thing in the universe, takes over 23 hours to travel from the sun to Voyager 1. Think about that. A message sent from Earth traveling at light speed takes nearly a full day to reach our distant probe, and its reply takes another day to come back. The probe's current location is a place of profound emptiness and discovery. It is bathed in the cold, tenuous gas and dust that drifts between the stars of our galaxy. Its instruments, though aging, continue to send back precious data about this unexplored territory. They measure the intensity of cosmic rays, energetic particles accelerated by distant supernovas. They sense the subtle hum of the interstellar magnetic field. We are for the first time directly sampling the environment of the Milky Way. Voyager 1 is our remote sensor, our robotic hand reaching out to touch the galaxy beyond our home. The journey to this point has been long. After flying by Saturn in 1980, its planetary mission was over. Its trajectory flung it up and out of the plane where the planets orbit. For more than 30 years, it sailed through the outer reaches of the heliosphere. It crossed a region called the termination shock, where the solar wind begins to slow down dramatically. Then, it spent years traversing the heliosheath, a chaotic, frothy region where the solar wind piles up against the pressure of interstellar space. Finally, on August 25, 2012, its sensors detected a sharp change. The familiar particles from our sun vanished, replaced by a flood of galactic cosmic rays. It had crossed the line. Now, Voyager 1 is a ghost ship sailing on an endless ocean. Its nuclear power source, a plutonium battery, is slowly fading. Sometime around today, in 2025, mission controllers will have to start shutting down its scientific instruments one by one to conserve power. By the 2030s, it will likely fall completely silent. Its voice will be gone, but its journey will not end. It will continue to coast silently through the void, carrying its precious cargo. It will travel onward for thousands and tens of thousands of years, a testament to the moment in history when a curious species on a small blue planet dared to reach for the stars. So what is this next great frontier for Voyager 1? It is a place of legend, a vast spherical shell of icy bodies that surrounds our solar system. We call it the Oort Cloud. This is the true outer boundary of the Sun's kingdom. We have never seen it directly. It is too far, too dark, and its objects are too small and spread out. Yet we know it's there because it's the source of the long-period comets that occasionally fall into the inner solar system. The Oort Cloud is a ghostly halo of trillions of frozen comets, remnants from the formation of the solar system held loosely by the Sun's gravity. It is the final frontier. The journey to reach this cosmic cloud is staggering. Even traveling at over 38,000 miles per hour, Voyager 1 will not encounter the inner edge of the Oort Cloud for about 300 years. Imagine that. 3 centuries from now, long after everyone who built and launched the probe is gone, it will finally arrive at the doorstep of the Sun's outermost realm. This is a timescale that dwarfs human history. It reminds us that our cosmic endeavors are not just for us, here and now. They are gifts we give to the future, messages sent to generations we will never know. Once it enters the Oort Cloud, Voyager's journey is far from over. This cloud is not a wall. It is a region of incredible size. It could be up to a light year thick, or even more. To pass completely through it and emerge on the other side could take Voyager 1 as long as 30,000 years. 30 millennia! That's a span of time that takes us back to when our ancestors were painting images on cave walls. By the time Voyager 1 finally emerges from the Oort Cloud, human civilization on Earth, if it still exists, will be unimaginably different. The probe will have traveled through the Sun's last and largest domain. Only then, after a 30,000-year trek, will Voyager 1 truly be free. It will have passed beyond the last vestiges of the Sun's gravitational embrace. It will become a wanderer among the stars, an object no longer belonging to our solar system but to the galaxy at large. Its path will be determined by the gentle gravitational nudges of other stars as it drifts through the Milky Way. This incredible timeline, from 300 to 30,000 years, is not just a set of numbers. It is a profound lesson in humility. It teaches us about the true, awe-inspiring scale of the cosmos and our own small but significant place within it. Voyager 1 is more than a machine of wires and sensors. It is a symbol. It represents the best of what it means to be human, our boundless curiosity, our ingenuity, and our desire to explore. It is an extension of our senses, traveling to places we cannot yet go. And as it travels, it carries a message. Attached to its side is a golden phonograph record, a time capsule from Earth. This golden record contains the story of our world, told in sounds, images, and music. It is a greeting to any civilization that might one day find our lonely probe drifting between the stars. The contents of the golden record were chosen to represent the diversity of life and culture on Earth. There are greetings in 55 languages, starting with an ancient Sumerian greeting and ending with a modern Chinese dialect. There are sounds of nature, like wind, rain, and the calls of animals. And there is music, a 90-minute selection ranging from Bach and Beethoven to Chuck Berry and traditional folk songs from around the world. It is a cultural Noah's Ark, a bottle thrown into the cosmic ocean. It says, this is who we were, this is what we valued, this was our world. The odds of another civilization finding this tiny spacecraft in the vastness of space are infinitesimally small. The record will likely travel unheard for billions of years, long after the sun itself has died. But its true audience was never really aliens. Its true audience was us. Creating the golden record forced a group of scientists and artists led by the great Carl Sagan to ask a fundamental question. How would we represent all of humanity? What is the story we want to tell about ourselves? The record is a mirror held up to our species, reflecting our hopes and our aspirations for a unified, peaceful world. Voyager 1's journey into the vast, dark expanse is a powerful metaphor for the human spirit. It is an act of incredible, multi-generational optimism. We sent it knowing we would never see the end of its voyage. We sent it for the sake of knowledge itself, for the pure joy of discovery. Its silent, endless journey reminds us that our quest to understand the universe is a journey without a final destination. It is a continuous process of reaching, of wondering, and of looking up at the night sky and daring to imagine what lies beyond the horizon. And that, in itself, is a destination worth striving for.